Imagine a force so immense it reshapes continents, a geological giant that doesn't just tower over landscapes, but swallows them whole. We're not talking about your typical cone-shaped volcano, spitting fire and ash. No, this is something far grander, a slumbering behemoth with the power to dwarf even the most imposing mountain ranges. Today, we delve into the awe-inspiring world of supervolcanoes, uncovering the secrets of the volcano that dwarfs mountains. When we think of volcanoes, Mount Vesuvius, Mount St. Helens, or even the majestic Mount Fuji often come to mind. These are stratovolcanoes, characterized by their conical shape and explosive eruptions. They are powerful, certainly, but their scale pales in comparison to the subject of our exploration, the supervolcano. A supervolcano isn't defined by its height, but by the sheer volume of material it can erupt, specifically more than 1,000 cubic kilometers of magma. To put that into perspective, the 1980 eruption of Mount St. Helens released about 1 cubic kilometer of material. A supervolcano can unleash 1,000 times that amount. These colossal systems don't build towering peaks. Instead, they create vast depressions known as calderas. These calderas can span tens of kilometers, often so large they are only truly visible from space. They are the scars left behind by cataclysmic eruptions, evidence of a geological power almost beyond human comprehension. Supervolcanoes typically form in two main geological settings: subduction zones, where one tectonic plate slides beneath another, and more commonly, over hotspots. A hotspot is an area in the Earth's mantle where heat rises as a thermal plume from deep within the planet. This intense heat melts rock, creating magma that rises towards the surface. As tectonic plates move over these stationary hotspots, a chain of volcanoes can form, with the most recent one sitting directly above the plume. While we often focus on the potential future threats, supervolcanoes have a rich and devastating history. Let's look at some of the most significant events. One of the most infamous examples is the Toba supereruption, which occurred approximately 74,000 years ago on the island of Sumatra in present-day Indonesia. This event is estimated to have ejected around 2,800 cubic kilometers of material, creating a caldera over 100 kilometers long. The eruption led to a volcanic winter, plunging the Earth into a decade of severe cold and potentially triggering a bottleneck in the human population. The sheer volume of ash and sulfur dioxide injected into the stratosphere blocked sunlight, disrupting global weather patterns and causing widespread crop failures and environmental devastation. This wasn't just a regional disaster, it was a planetary event. Closer to home, in the United States, lies the Yellowstone caldera, often considered the most famous supervolcano. Yellowstone has experienced 3 immense eruptions over the last 2.1 million years. The first, 2.1 million years ago, formed the Huckleberry Ridge Tuff and created a caldera spanning over 100 kilometers. This was followed by the Mesa Falls eruption 1.3 million years ago, and the most recent major eruption 630,000 years ago, which formed the present-day Yellowstone caldera. Today, Yellowstone is a vibrant national park, known for its stunning geothermal features like Old Faithful. These geysers, hot springs, and mud pots are direct evidence of the immense heat and volcanic activity bubbling beneath the surface. It's a constant reminder of the powerful, restless giant sleeping below. Another significant supervolcano in North America is the Long Valley caldera in eastern California. Formed about 760,000 years ago during the massive Bishop Tuff eruption, it released an estimated 600 cubic kilometers of magma. This eruption was so powerful that ash was carried across the continental United States. The idea of a supervolcano erupting in the modern era is a topic of intense scientific study and public fascination. While the probability of such an event in any given year is extremely low, the potential consequences are staggering. An eruption of a supervolcano like Yellowstone would not be a localized event. The immediate area would be devastated by pyroclastic flows, fast-moving currents of hot gas and volcanic debris. Ashfall would blanket vast regions, disrupting agriculture, collapsing buildings, and rendering infrastructure inoperable. Air travel would cease globally due to the dangers of ash to aircraft engines. Beyond the immediate physical destruction, a super eruption would trigger a volcanic winter. The massive release of sulfur dioxide into the atmosphere would form sulfuric acid aerosols, reflecting sunlight and causing global temperatures to plummet. This sustained cooling would lead to widespread crop failures, famine, and a severe disruption of ecosystems worldwide. The impact on human civilization would be unprecedented. Scientists at the United States Geological Survey and other institutions continuously monitor active supervolcanoes like Yellowstone. They use an array of tools, including seismometers to detect earthquakes, GPS to measure ground deformation, and gas sensors to monitor volcanic gas emissions. These measurements provide crucial data, helping researchers understand the subterranean processes and identify any potential signs of unrest. Understanding the behavior of supervolcanoes is critical for developing disaster preparedness plans and mitigating potential risks. While we cannot prevent these colossal forces of nature, continued research and monitoring allow us to be better prepared for their rare but immensely impactful awakening. We hope that you will like our effort. If you like the video, please subscribe to the channel and like it. Take great care of yourself and your loved ones. See you soon!